Previously, we created an endpoint that returns the transactions within a user's transaction pool instance. However, we're missing the equivalent method that actually adds new transactions to that pool. The paired method to a get endpoint is a post endpoint. So let's add a new post method that handles adding transactions to the pool. We'll call this method transact because after all, users will transact whenever they use this endpoint. So let's make a new post request similar to the mine post request, but this time the endpoint will be /transact. Then we have our request response callback parameter for the second parameter to the post function on the app instance. The goal of this method will be to create a transaction with the user's wallet. Transactions consist of a specified recipient and amount. We'll assume that the recipient and the amount are given by data that the user sends over the post request. So let's grab the recipient and the amount using ES6 destructuring syntax from the body object within the request object that is created in this post function. So with that, we're ready to create a transaction with the user's wallet instance. We'll create the transaction with the given recipient and amount from the request body. Then we'll pass in the transaction pool as the last necessary parameter for this function. So we're creating a transaction variable that is equal to wallet.createTransaction, and then we're passing in the recipient, and then the amount that we received, and then finally the local transaction pool instance. And this creates a transaction using the local wallet instance of this application. Finally, we'll give the output of the transactions endpoint so that way the user can immediately see the new transaction in the actual pool. So we're going to redirect to the existing /transactions endpoint. So the final result of the transaction post is to create a transaction and then redirect to the existing transactions get endpoint so that way they actually see the new transactions array within the transaction pool so that way they can see their new transaction. All right, perfect. That completes the new transaction post request. Let's test it out. If you still have the application running on the command line, then go ahead and open up Postman already. Otherwise, go to the command line and then run npm run dev to start up the app. Once you have the app running, you should see listening on port 3001. And now you're ready to open up the Postman application so that way we can send a request to the new transact endpoint that we set up. So once Postman is open, we're ready to create a new tab, and this tab will be a post request. And the URL is localhost port 3001/transact, which is the URL of the new endpoint that we just created. Since this is a post request, we want to change the body. We'll select raw so that way we can make the body JSON application/JSON. And then this JSON is arbitrary. So let's make a recipient. And how about the address of the recipient is foo 4D R355, which looks like foo address. And then this needs an amount. So the transact endpoint assumes that an amount is provided with the body object of the post request. And this can be arbitrary too. So how about something like 50? All right. So one thing you can do is press Command S to save the request to a specific folder. Notice that there's an sfchain folder over here. Later on in the project, we're going to be doing the transact post endpoint a couple more times. So it will be quite useful to have this fully loaded so that way you can reuse it whenever you want without having to retype the body part. Even though it's not that long, it just saves a little time as we're developing. So with that fully created, we can click send a couple times. So let's send this request. And as we do so, and you scroll down, we see that we have one transaction object in the array of transactions. And check it out. It has the input of the wallet that we created with its super long hash address. Likewise, it creates outputs for itself, and then ones for the foo address. However many times you click the send button is however many output amounts will be for the foo address. And then you'll see that it totals up to the input amount if you add up all of the output amounts. So it looks like everything is working properly. Excellent. We've now directly interacted with the individual wallet for the user, and seen the updating transaction feature in action too. Next up, let's consider that multiple users of the blockchain application will be conducting transactions. This means everyone will have their own transaction pool objects. But as users submit transactions, we want each transaction pool to be synchronized. After all, for transactions to be valid, people in the network beyond one individual need to be aware of that transaction itself. So let's sync up the transaction pools of each user that runs our application connected on the same network by incorporating the transaction pool object within our peer-to-peer server.